When you call a method that expects a delegate to be passed to it, in some situations, it would be great if there was a way to define that method in line. There certainly is. You may have heard about something called a lambda, or anonymous function. This is a concept that exists in both mathematics as well as in computer science. As a really simple example, consider that we want to express a function that accepts an order as a parameter and returns true or false, depending on if the order has items added to it or not. C# provides two ways of expressing this using a lambda. The result of expressing a lambda will be an anonymous function, which you use like any delegate. The basic pattern to follow is that on the left-hand side, you express the expected parameters within parentheses. You then use the arrow syntax, also known as the lambda operator, and on the right of the arrow, you have two ways of defining the body of the lambda. Either you use an expression or a statement. These two alternatives are known as lambda expression and lambda statement. Using an expression is a simple way to define a one-liner. This should be kept short and neat to make it easy to understand. A statement looks much like a method body. This is what you'd use for more complex lambdas, where a bit more happens inside the body of the anonymous function. The C# compiler will do its best to determine all the types used in the lambda. If it can, it will infer the types for the parameters based on where you use it. It will also determine the correct return type. You can explicitly define these yourself. Let's look at this in our application. Remove most of the code that creates the chain. Instead of using the methods that we've defined earlier, we are going to create a chain using lambdas. To create an anonymous function for the process completed delegate, you need to express a lambda that accepts a parameter and that doesn't return anything. For anonymous functions that do not return any value, you have to use the lambda statement or point to another method that returns void. This is because the whole idea behind an expression is that it yields a result. You start your lambda statement with the expected parameters. This is done with a method-like syntax. You can name the parameters whatever you want. All that matters is that the number of parameters is a match to the delegate. If you explicitly declare that the parameter is of a type that cannot be derived from the delegates, you will get a compiler error. It's better to let the compiler figure out the type for you, where possible. Even though the parameter is only used inside the scope of this anonymous function, it's wise to give it a good and descriptive name. Add a console output to the anonymous function. Now that we've defined the first delegate in the chain using a lambda, we can try and append a second one. Just like earlier, you can use addition. If you run the application, you can see that it does indeed run the anonymous function without having to create new methods that are available throughout the class. You can simply pass along an anonymous function, which sole purpose is to cater for the delegated functionality. Look at this. There's one thing that immediately comes to mind that is going to be different from what we could do before. How would you remove one of these delegates from the chain? It's clearly not as simple as subtracting the method. as the anonymous function isn't available to reference. While lambdas make it extremely simple to express functionality passed to methods that require a delegate, this is one of its drawbacks. We'll talk more about this in the next module, where we look at events, as it's something you should really keep in mind. Let's completely remove the chain and instead pass only one delegate expressed using a lambda to the process method. This would mean that we can completely remove the send confirmation email method. We've now reduced the amount of code in the program, and we've maintained the functionality. Of course, if the anonymous function would have been a bit bigger than just a handful of lines, it would have been wise to extract that to a separate method. Use this to reduce complexity and increase readability. Now that we've seen the lambda statement, let's give the lambda expression a try. For the onOrderInitialized delegate that we pass when the order processor is instantiated, we can replace this method reference with an inline anonymous function that we declare using a lambda expression. Just as with the lambda statement, you start with the parameters that are passed into this anonymous function, and then on the right-hand side of the arrow syntax, we create the expression. This delegate, as you may recall, requires a Boolean to be returned. As an example expression, we can check if the order has been marked as ready for shipment. If it hasn't, this expression will return false. You could also construct more complex expressions. It could even involve method calls. As a word of advice, I would recommend that you keep it as simple as possible. And if it gets too complex, you can always extract portions of that into separate methods. I want you to take a moment to think about what we've just done here. We changed the delegate. Instead of sending a message to the warehouse, it instead checks on a completely different property. This means that the order processor and how it handles the order is now completely different from the earlier implementation. This really highlights the usefulness of delegates, lambdas, and anonymous functions. Applications may share access to this business layer that exposes the order processor, and they could all supply their own logic for how to handle this delegated logic. As mentioned earlier, the compiler will infer both the return type as well as the parameters. But you can explicitly define all of these if you'd like to. The return type is defined right before the parentheses, where you declare the parameters. And the parameter types, well, they're defined together with the parameters. Another big benefit of using anonymous functions is that it can capture variables from the current scope. If you introduce a variable in the program, you could use that in one of these lambdas. This is a huge benefit over simply pointing to a different method. When you capture a variable, it's worth to mention that it will only be disposed when the delegate is no longer used and is marked for disposal. If you want to ensure that the anonymous function do not introduce any side effects in terms of changing variables in your scope, or even being able to capture those variables, you can declare this as static. This acts just like a normal static method. You could, of course, capture static variables in the current scope.